Module 1, Measurement, Units, and the Scientific Method. Derived Units. As you were going over the factor label method in the last few sections, notice how you manipulated the units in the mathematical expressions in the same way you would manipulate numbers. Well, there are rules that govern the use of these units in math, so let's go over them now. When adding and subtracting units, the units have to be the same. You can add or subtract liters and liters, or milligrams and milligrams, but you can't add or subtract liters and kiloliters, or grams and centigrams. You first have to convert the measures so that the units are the same. It's like adding apples and oranges. Apples and apples can be added together, but apples and oranges need two separate units. They have to be the same to combine the number. So once the units are identical, we can add or subtract them according to algebraic rules. Just like we can say 2 apples plus 3 apples equals 5 apples, we can say 2x plus 3x equals 5x, or 2 centimeters plus 3 centimeters equals 5 centimeters. Get it? And we can subtract this way too. 6.3 milligrams minus 3.0 milligrams equals 3.3 milligrams. So whenever you are adding and subtracting with units, make sure they are the same, and then just carry the unit into the answer. Now let's discuss multiplying and dividing units. Just as in algebra, multiplying or dividing units doesn't require that the units have to be the same. So if we have 3x times 4y, we get 12xy. And if we have 3 milligrams times 4 kiloliters, we get 12 milligram kiloliters. When dividing, if we have 12x divided by 2y, we get 6x over y. And when dividing units, if we have 12 grams divided by 2 milliliters, we get 6 grams over milliliters. So let's try a few. If we want to measure the area of a room, we would multiply its length times its width. So if it is 10.1 meters by 8.5 meters, we would multiply the numbers 10.1 times 8.5 and get 85.85. Then if we multiply the meters times the meters, we would get meters squared, or square meters. Square meters is a metric unit for area. Say you measure a domino to be 56 millimeters long, 8 millimeters wide, and 28 millimeters in height. Volume measurements for box-shaped items are length times width times height. So we multiply the numbers 56 times 8 times 28 and get 12,544. The units are also multiplied to be millimeters times millimeters times millimeters, so we get millimeters cubed, or cubic millimeters. So our answer is 12,544 cubic millimeters for the volume of the domino. For larger boxes, you may use centimeters, meters, or kilometers, resulting in volumetric measurements of cubic centimeters, cubic meters, or cubic kilometers. The units are determined by the information you're given. Now, units like cubic centimeters or square millimeters are called derived units because they are derived or are a result of math calculations. Let's say you have a box with a volume of 5.208 cubic centimeters. You want to know that volume in cubic meters. You might think that the factor label method would be set up like this, with the volume value over 1 times the conversion factor of 0.01 meters over 1 centimeter. But notice the 2 centimeter values. One is cubic centimeters and the other is centimeter. They are not the same, so they will not cancel out. The units in the numerator and the denominator need to be exactly the same for them to cancel. So we have to fix the centimeter unit in the denominator so it will be cubic centimeters. Well, because volume is a measure of length times width times height, you have to provide a conversion factor for each of these 3 centimeter units. So we need to have 5.208 cubic centimeters over 1 times 0.01 meters over 1 centimeter times 0.01 meters over 1 centimeter times 0.01 meters over 1 centimeter. Cubic centimeter is really just centimeter times centimeter times centimeter. So now the centimeter units are the same in the numerator and the denominator. In fact, we can simplify this by cubing the conversion amounts so that our original measurement is multiplied by 0.01 meters over 1 centimeter, the whole quantity cubed. Now we can cube the numerator to be 0.000001 meters cubed. The denominator is also cubed to become 1 centimeter cubed. At this point, the cubic centimeter units can cancel out, leaving only cubic meters as our desired unit. So multiplying the numbers, our final answer is 0.000005208 cubic meters. This means that a volume of 5.208 cubic centimeters is the same as a volume of 0.000005208 cubic meters. Cubic measurements are volumetric measurements. Well, we already talked about the liter being the metric measure of volume. So what's going on? It turns out that a cubic centimeter is equivalent to a milliliter. In fact, if you've ever had a doctor or nurse referring to how much liquid to put in a syringe for a patient, they will use the term cc's. cc stands for cubic centimeter. So a medication dose of 5 cc's is a dose of 5 milliliters. This is an important relationship, and you need to make sure you memorize it. 1 cubic centimeter is the same as 1 milliliter. So let's take all of what we've covered and put it together into a practice problem. A box's measurements are 1.1 inches in length, 3.2 inches in width, and 4.6 inches in height. What is the box's volume in liters? Well, let's first plan our attack as we look at this problem. We're given length measurements in inches, which is an English measurement. We're looking for liters, which is a metric volume. So we need to first figure out the volume of our box in English units, then convert that volume to metric units, then convert those metric units to liter measures. The formula for volume of a box is length times width times height. So we can write our problem as V equals 1.1 inches times 3.2 inches times 4.6 inches, which equals 16.192 cubic inches. Now we need to convert this amount into liters, but there isn't a conversion from cubic inches to liters, is there? So we need to make a series of conversions to get there. Is there a conversion from inches to centimeters? Yes. 1 inch equals 2.54 centimeters. So we can convert now. What do we have? We have 16.192 cubic inches. Set that over 1. The conversion needs to be set up in a fraction so that the cubic inches unit cancels. So we can write a fraction of 2.54 centimeters over 1 inch, but notice that this isn't cubic inches. We need to cube this fraction or multiply it times itself 2 times. By doing this, we get the conversion relationship as 2.54 times 2.54 times 2.54, or 16.387 cubic centimeters over 1 times 1 times 1, or 1 cubic inch. The cubic inches can now cancel out, leaving our answer in cubic centimeters. Notice how our units help us to figure out what to do next. Multiplying the numbers in the numerator and the denominator, we get 265.338 cubic centimeters. Is that our final answer? No, we need our answer in liters. But we do have a relationship between cubic centimeters and milliliters, don't we? So let's do another conversion. What do we have? We have 265.338 cubic centimeters. Let's make it a fraction by placing it over 1. What's our conversion between cubic centimeters and milliliters? 1 cubic centimeter equals 1 milliliter. This is a 1-to-1 ratio, so when we set up that in a conversion fraction, you see that we're just canceling out cubic centimeters and we will have the same number of milliliters. Now we can finally convert milliliters to liters. 265.338 milliliters over 1 is what we have. What's the conversion relationship? 0.001 liters in 1 milliliter. Set this up as a fraction so that milliliters cancel out. We're left with liters as a unit. Multiplying the numbers, we get 0.265338 liters. So the final volume of the box is 0.265338 liters. Now, this isn't the only way to do this problem. We could have taken the 3 initial measurements that were in inches and converted each of them to centimeters. That would be 3 conversion problems. If we did that, we would multiply each measure by the conversion. Then we would have 2.794 centimeters, 8.128 centimeters, and 11.684 centimeters. The volume of our box then would be V equals length times width times height, or 2.794 centimeters times 8.128 centimeters times 11.684 centimeters, or 265.338 cubic centimeters. Cubic centimeters is the same thing as milliliters, so this number can also be expressed as 265.338 milliliters. That can then be converted to liters using the conversion factor of 0.001 liters over 1 milliliter, causing the milliliter units to cancel. The answer then is 0.265338 liters, just as we calculated before. If you feel a bit unsure about conversions, don't worry. Work the on your own problems and then the practice problems in the back of this module, and you will begin to eventually get it. The best way to learn these processes is to practice doing them.